How did the EPR paradox challenge quantum entanglement? Imagine two particles that are connected in a way that no matter how far apart they are, measuring one instantly tells you about the other. Sounds like science fiction, right? Well, that's exactly what quantum entanglement suggests. But back in 1935, three physicists named Albert Einstein, Boris Podolsky, and Nathan Rosen had a different idea. They thought this strange connection might mean that quantum mechanics wasn't the full story. They called it the EPR paradox, after their initials. They imagined creating two particles together and then sending them far away from each other. When you measure the state of one particle, the other would instantly change, no matter the distance. Einstein called this spooky action at a distance because it seemed to break the rules of how we think the universe works. According to Einstein, nothing should be able to travel faster than the speed of light, so how could these particles be communicating instantly? The EPR paradox raised a big question. Was quantum mechanics incomplete? Einstein and his friends believed there must be hidden variables, unknown factors that determined each particle's properties from the start. They thought that if these hidden variables existed, then the particles wouldn't need to communicate at all. Instead, everything would be set in stone from the beginning, making the universe more predictable and local. But then, in the 1960s, John Bell came along with a way to test this idea. His theorem showed that if hidden variables were responsible, then certain statistical inequalities, called Bell's inequalities, would never be violated. Experiments, however, kept showing that these inequalities were broken. This meant the particles really did behave in ways that couldn't be explained by local hidden variables. The results proved that quantum entanglement is real and that the particles are connected in a way that defies classical ideas. It's not just a weird theory, it's a fundamental part of how the universe works. The EPR paradox pushed scientists to accept that entangled particles share a single quantum state and that measuring one affects the other instantly, no matter how far apart they are. This challenge to classical physics opened the door to many new discoveries. It helped develop quantum technologies like quantum cryptography, which uses entanglement for super secure communication. It also led to quantum computers that can process information in ways traditional computers can't. So, the EPR paradox made scientists question everything they thought they knew about the universe. It showed that quantum entanglement isn't just a strange idea. It's a real, fundamental feature of nature that keeps surprising us with its weirdness.